So you can often think about list accumulation as filtering. And I'm going to give just another quick example of a list accumulator. This one will, we'll just make some list, and let's put a bunch of numbers in it. And let me just comma these out. What we're going to filter is numbers greater than 3. And that's our accumulator right there on line 6, right? So for num in LST, if num greater than 3, then we append greater than 3, append num, and we can see if I print greater than 3, we should see only numbers greater than 3 that are from that original list. And that's what we're seeing. So pretty easy that. This is a maybe a simple filter, which is fine. But I want to give you kind of a practical use case as well. So 0, 4, dog, right? We have some mixed data in here, and let's do elephant. And let's make this a function again. So def filter filter nums. Let's do that. And this is going to take in some num list, or it's going to take in some list. I have this habit of naming things, reusing names as parameters. So maybe I won't name it that. Let's call this dirty list. And just change it here, dirty list. Cool. And then we need our accumulator, which is not going to be greater than 3. Let's name this clean list. So for num and dirty list, if num, this won't be a num. This will, well, it still will be. Let's call it element. Let's call it elem. If the type of elem is not an int, and the type, let me do it like this, is not an int, and if the type of the element is not a float. So let's say that we're accepting, in this case, we're accepting either ints or floats. So this, it needs to be an int, right? So I can do this on 2 separate lines. Oh, no, I can't. My mistake, I almost made a logical error there. So if the type of the element is an int or the type of the element is a float, we're going to append it to the clean list, and then we want to return that clean list. So let's go ahead and return clean list, and I'm going to go ahead and call filter nums on LST, and we get an error. Name num is not defined. Of course it's not. Huh. Where is it? Oh, there it is. I named that lm, so notice here we have a list that's been cleaned. So there's a lesson later on filter, map, reduce, But this is a good first look at the concept of filtering, and it's something that we're applying an iterative process here that takes up the memory, takes up the processing for the duration of this for loop, which is fine. It's not highly parallelized. It's parallelized enough, but don't worry about any of that. This is a simple filter, and you can imagine we could change this to filter out the letters, and we could just instead of filtering nums, we could filter letters, and that would be the same pattern.